Hello, in this video we'll cover the basics of Java servlets. In this class, we will create web applications as Maven projects in Eclipse. So if you haven't set up your development environment or haven't finished the Introduction to Maven lecture, please do those first, then come back and continue with this video. Now let's brush up on the big picture. We now know how to create web pages and how to put them on a web server. A user can use a browser to request a web page using the HTTP protocol, and the server simply sends the requested page back. We call this the static web because we have to create those web pages in advance, and once created, they don't change. If we want to create dynamic content, like a Google search result page or an Amazon shopping cart page, excuse me, we have to make two changes. First, we need to replace the pre-created web pages with a program, and this program will dynamically create a web page based on the request. And second, we need to replace a HTTP server that's only capable of returning files with what we call an application server that's capable of running these programs. There are many different ways to create such programs. We can use many different programming languages and many different web development frameworks. The ones we will study in this class are technologies using the Java programming language. Now, let's create a simple web application, and we'll use this application to explain some basic concepts. As we talked about in the Maven lecture, we will create a web application as a Maven object, and we are going to use this Maven archetype called simple servlet archetype. And I'll use this as a group ID, artifact ID, or call it web test. And for the top level package, I'll just say CF3220 and uncheck run archetype generation interactively because we already provided all the necessary information. And okay, so the project is created, and it's right here. So the simple servlet archetype gives us a couple of sample files. One is this hello servlet.java, and one is this index.html. So we can run this servlet, for example, by right-clicking on it and then select Run As, and then Run on Server. And since we have already done this before, we already have a server here in Eclipse, and I'll check always use this server and then finish. And now we see something. And if we take a look at the servlet, it basically prints out hello world inside a level 2 heading, and this is basically what we got. And we can look at the source code of the page, and it is indeed hello world in a level 2 heading. So before we do anything else, let's first understand what happens when we run a web application. So first, Eclipse will deploy the web application to an application server. Basically, it looks like this picture. The Eclipse will put the application on an application server. Note that this is different from a desktop application that runs on our own computer. a web application needs to run off an application server. But of course, during development, it'd be quite inconvenient if we have to use two computers to write and debug one program. So Eclipse creates an application server on the same computer. The application server we chose is Tomcat version 9. Tomcat is a very popular Java web application server, and version 9 is a very well supported version on major server operating systems. But even more importantly, Tomcat 9 is the default embedded server in the Spring Boot framework, which we'll study later. There are also many other Java web application servers which you may encounter sometime in the future, like Jetty, Undertale, JBoss, and so on. For our purpose, all these servers do the same thing, which is to run Java web applications. Okay, so Eclipse deploys the web application to a local server that opens a browser, and the browser then sends a request to the server. Then what happens? Well, then what happens depends on what request is sent. So if we run a servlet, and this is the URL of the request sent by the browser. And we can see this URL here. This one, localhost 8080, webtest hello servlet, and right here. Now, the first part of this URL basically says it's a HTTP request sent to the server running on localhost at port 8080, and that will be the local Tomcat server that we have. And the rest is used by the server to decide how to handle this request. The server will use the first segment of the path to locate the web application, which is this web application, and there could be multiple web applications running on the same server. And the rest of the path is used to find a servlet that handles this request. Note that the last part is not necessarily the servlet name, so our servlet is indeed called hello servlet. But the last part is not necessarily the name. It's so-called servlet mapping. And servlet mapping is actually defined here. And we'll talk more about servlet mapping in a moment. Basically, this one is the servlet's way to say, I'm going to handle all the requests sent to this URL, and if a request is sent to that URL, this servlet gets invoked. So once the servlet is found, the application server will run the servlet and sends back the response generated by the servlet. Most of the interactions between browser and servlet work like this, but there is a special case. The special case is when we run the project. If I right-click on the project and then say run on server, and you can see that this is the URL, or this is the URL. And notice that the request is sent to the root path of the application. If the application doesn't have any servlet mapped to the root path, the server will try to send back a so-called welcome file. The default names for welcome files are index.html, index.htm, and index.jsp. We happen to have index.html file here. So the server will send back this file, and this is what we see here, which is this file. Of course, you may be wondering, what if we don't have this file? Then it's simple. The server cannot find anything that handles the root path. It cannot find any welcome file, so it simply returns a full for page not found error. To summarize, once a web application is deployed on a server, all the interactions between a browser and the application follow the same request-response process. For example, if we click on this link, notice the URL here. The server basically sends another request with this URL, and the server handles it just as what we have described here. Okay, now that we are clear about the big picture, let's take a closer look at the code. This is what a simple servlet looks like. There are quite a few things here that need explanation though. Let's start with some simple observations. First, note that unlike regular Java applications we are familiar with, there is no main method here. This is because a servlet or server-side programs in general are run by application server instead of a user. So instead of a main method, there is a method called doGet, which is called when the server receives a request. The server passes this request to the doGet method as the parameter request. So notice here that there are two parameters to the doGet method, a request and response. Request is passed from the application server to this method, so this method can process this request. And then the method can populate whatever it wants to send back in the response. So in this example, it writes hello world into the response, and that gets sent back to the browser. So in other words, the HTTP request is the input that we use, and the HTTP response is the output we try to produce. In the next lesson, we'll take a much closer look at HTTP request, and at that time, it will also become clear why this method is called doGet. Basically, it's a method handle GET requests. Another observation here is that the servlet class needs to inherit from the superclass HTTP servlet. And you can imagine that this class contains code that takes care of the interaction between the servlet and the application server, so our code can focus on implementing the application logic. Now let's look at the response part. In most cases, the response should be an HTML page. To do that, there are a couple of methods that we'll use most often. The first method is the setContentType method. As we use it here, it's a method of the response class. So response.setContentType. This method sets the content type of the response, and if the response is an HTML page, it should be text/HTML. And we'll talk more about content types in another lecture when we look into responses. And then another commonly used method is this getWriter method. It returns a writer object which we'll use to write content of the HTML page into the response. So it looks like this. We'll say getWriter, and then later on we can use writer to write whatever we want into the content. And whatever we write here will appear in the user's browser. You can see that we wrote 3 lines, and the first line, the second line, and the third line. And it is exactly how it looks in the generated HTML page. Okay, so now that we know how to generate an HTML page, let's look at servlet mapping, which is this part. In a web application, there are usually more than one servlet, and which servlet should be used to handle a request is determined by servlet mapping. Servlet mapping takes a path component of a URL and then tries to match it to the URL pattern declared by a servlet. If a match is found, that servlet is used to handle the request. As we see in this example, this servlet declares that it handles this URL pattern / hello servlet, and when a request comes in and matches that URL pattern, this servlet is invoked. And that servlet pattern is declared using something called Java annotation. Most of you probably already either used Java annotations before or at least saw some Java annotations in some code. It's a language feature introduced in JDK 1.5, aka Java 5. Annotation basically it's not part of the code of a program, but it can be used to provide some information about the program. Nowadays, annotations are very, very widely used in Java development for various purposes, especially in web development. Here are some examples of Java annotation. For example, it can be used to indicate a method is overriding a method in the superclass. And if we use this annotation, the IDE will help us to check if this overriding is correct. For example, it will show an error if we forget a parameter in the subclass method. And this annotation is used to suppress some compiler warnings. And this annotation is this one, which is used to declare servlet URL patterns. And these annotations are used by some web service libraries to turn some classes and methods into web services. All in all, annotations are very, very useful, and we will encounter quite a few of them later on. There are a few more things we need to know about annotations. First, annotation may have elements. For example, when we write a web servlet, when we write as web servlet annotation, we can specify the URL pattern using the value element, which would look like this. Note that the element here looks like an attribute in an HTML tag. So although the official name is element, I often call them attributes, so don't get confused. The default element for Java annotations is value. So this is not just a element for web servlet annotation is actually the default for all Java annotations. And if there's only one element and it is the value element, then the element name can be omitted. So although technically the annotation should look like this, but we can omit value because it is a default. Just like variables in Java, each element has a type, and element types can be some simple types like numbers, strings, arrays, and other annotations. The type of the value element here is actually a string array, and this allows us to map multiple URL patterns to the same servlet. For example, we could say this servlet will handle hello servlet, and it will also handle hello world. So we specify the value as a Java array, and if we save it and wait a little bit for the server to reload, and we can go back and refresh, and hello servlet still works. And if we say hello world, and notice that hello world URL now also works because we are mapping both URLs to this servlet. And we can do that by specifying the value as a Java array. With that being said, in most cases, we only map a servlet to one URL pattern, which is like this. And the annotation syntax says that if there's only one element in an array, the array braces can be omitted. So we are back to this, and since there's only the default value element, we can further omit the value element name, and this is the most common URL mapping pattern that we see. Now let's take a quick look at the documentation of the web servlet annotation. So we can see that it has quite a few elements, aka attributes, but all of them are optional. We don't need to worry about most of these elements except 3 of them, which is value and URL patterns, and also lowdown startup. Lowdown startup determines whether a servlet should be started when the application is deployed, and we'll talk about lowdown startup a little bit later. Now, regarding value and URL patterns, both of these elements actually serve the same purpose, which is to declare the URL patterns that a servlet handles. One of these elements must be specified for the annotation, and the convention is to use value if we only need to specify URL pattern, servlet mapping, and to use URL patterns if we need to specify other elements as well. It's a little bit confusing, and I think it's an unnecessary design to introduce 2 elements essentially for the same purpose, but that's how the servlet specification says. So here are some examples of using the servlet, web servlet annotation. The first one is what we usually see if we want to match multiple URLs to the same servlet, we can use this form by specifying the URL patterns as an array. Notice that we can even have wildcard patterns inside a URL. Here's an example that shows when we specify two elements for web servlet. In that case, the convention is to use URL patterns instead of value. But if you just use value, it will work perfectly fine. But it's just a kind of a convention to use URL patterns in the case where we specify multiple elements. Same thing here. All right, now that we know the basics of servlet, let's learn a couple of more things. We'll first see how we can keep data in a servlet, and then we'll see how to share data among servlets. Let's first create a request counter servlet. When you visit some websites, sometimes you'll see a counter on the website that says you are visitor number 1000, or this page has been viewed 1,000 times, or something like that. And let's see how we can implement that. So I'm going to stop the server for now, and I'm going to create a new servlet. So just, I'm going to create it in the same package under cs3220.servlet. So right click on that and select servlet and give it a name, and I'm going to call it request counter. Okay. So Eclipse will kind of create a skeleton servlet, which is our starting point, and I'm going to get rid of all the comments, and also I'm going to get rid of do post, and let's copy over what we have here. Okay. So now we have a new request counter, and this request counter servlet, just like before, it prints out hello world, which we don't really want. So we need to update the output for each request, right? And each request comes in, we want to add one to our counter. So two things: A, we need to have a counter, and B, we want to display the counter value, and C, we want to increment it, something like that, right? So the simplest thing to do is, of course, we can declare a variable here inside the request counter class, and then we'll say something like you are visitor number something, right? And so we'll increment the counter here, and that will probably do it. Let's try it. So it says you are visitor number 1. I misspelled visitor. That's okay. If I refresh the page, it says visitor number 2, 3, 4, 5, 6, 7. Right. So this is how request counter can be implemented. You'll just keep a count somewhere, and every request comes in, you increment the count. It's a simple example, but I think first it's a good example to show, good and simple example to show how to create a so-called dynamic page, right? So this is not an HTML page that we pre-create because we don't know how many visitors a certain visitor is, right? And so we are essentially dynamically generate a page every time a request comes in. So even though it's a simple example, it is showing how to generate dynamic content. And secondly, oftentimes we need to keep some data within our application. And this is kind of the first step, showing that we can keep a simple counter and then later on retrieve the data and update it. Now this is pretty simple, but there's one problem. We are using a so-called instance variable to keep the count. Now this is fine if we only need that information for this one servlet. However, in most cases, a web application has multiple servlets working on the same data, and the instance variables cannot be shared among different servers. This is a little bit counterintuitive. In a regular Java application, we can certainly create some classes with some variables, and other classes can certainly use those variables, right? But the situation is a little bit different in a web application. In a web application, when a request comes in, a new thread will be created to handle the request, and different servlets will have different threads. So sharing data among different servlets is more like sharing data among programs rather than sharing data among classes in the same program. So effectively, in a web application, we are trying to share data from this thread with this thread, for example, and they are virtually like two programs. I don't want to get into the distinction between threads and processes and so on, but you can think of them as two different programs, and it's not easy to share data among those. So to address this issue, Java web applications provide something called the application scope. You can think of application scope as a common storage area that all servlets can access. And the data in application scope will remain there as long as the application is running. If the application is stopped or reloaded, the data will be lost. So in other words, it's not something that's written to disk or stored in a database. It's something stored in memory and can be shared by different servers. But if the application is stopped or reloaded, the data will be lost. The API to access the application scope is this. In a servlet, we can call getServletContext. This method returns a HTTP servlet context object, and then we can call setAttribute to save some data in the application scope as an object, and we can call getAttribute to get the data back. Notice that getAttribute will return a Java object type. So more often than not, we'll have to cast that object into an actual type, as we'll see in a moment. Okay, so knowing what we know, let's create another version of the request counter, and this time we are going to keep the counter in application scope. So instead of keeping it in an instance variable. So again, let me stop the server first. And what we do is we will use the init method. And inside the init method, we will create a counter, initialize it to 0, and then save it in application scope. So something like create a counter, initialize it to 0, save it in application scope. And so counter is 0, and then we say get servlet context and save attribute, set attribute. Set attribute, and then give it a name, and then save it in application scope like this. We could simply put 0 here and save us one line of code, but I just want to make it a little bit more clear. Anyway, so this one will save a counter into the application scope with the value 0, and here we need to get the current counter out. So we'll say integer counter is get servlet context get attribute. So we'll use this attribute name to get it out. And because it gets the attribute out as a Java object, we have to cast it to a Java integer, like this. Okay, now we have the counter, and we can do the same thing as before. We increment the counter, we display it. Right? But after that, we'll have to save it back. So it will be something like this. So save the updated counter back to application scope, and this part would be increment and display the counter, something like that. Okay, so if we run this again, well, it works like before, and with somewhat more code. Before we get to the benefit of doing things in this way, let's talk a little bit about the so-called lifecycle methods. So in our example here, we are using another method in addition to doGet, and this one is called init. So init is one of the servlet lifecycle methods. It's only called once when a servlet is started. So this is a very good place to do some initialization. Whenever a request comes in, a service method will be invoked, and based on the request type, which again we'll discuss in the next lesson, the request is dispatched to one of the do something methods like doGet, doPost, and so on. And this is why this method is called per request. And every time we get a new request, or every time we refresh a page, the counter will get incremented, because this one is called per request, while init is called only once. There's also a destroy method, which is called when the servlet is destroyed, and it's a good place to do some cleanup work, like releasing some resources held by the servlet and so on. And also note that servlet only gets destroyed when the server stops or when the application is removed from the server. You might be wondering why we initialize a counter in the init method rather than in the constructor. The answer is simple. There's no servlet context in constructor. If you call get servlet context in the constructor, it will return a null because servlet context is not constructed in constructor. And because of that, if we want to access application scope, we cannot do that in constructor. The way it works is that for a servlet, first its constructor is called to create the servlet object. Then its servlet context can be created and initialized. So anything relying on servlet context, like accessing the application scope, has to happen in the init method or afterwards, like in doGet. Okay, so coming back to the code, we went through lots of trouble to make sure that counter can be shared with other servlets. Now let's create another servlet to try to access this counter. So we will call this where is servlet? Here. We will call this display counter. So what it does is it tries to access the current counter and display its value. It doesn't increment the counter itself. And again, let's get rid of some code that we don't need. By the way, you can do a quick format document, Control-Shift-F to format your code. Okay, and here what we do is basically this. We will get the counter from application scope, and then we display the counter without incrementing it. And instead of saying your visitor something something, we will say the current counter value is counter, and that's it. Okay, so let's run this. And right now we are at request counter, and we'll refresh it a few times, and now it's at counter 10, and if we go to display counter, it will say the current counter value is 10. And this shows that, great, this counter value can be shared among servlets. And at this point, it seems like our example works fine, but there's actually a subtle bug in it. So let's say that, let me first stop the server, and let's run display counter first. So if we run display counter first, it actually says the counter value is null, and even though we are supposed to set the counter value to 0. So what's happening here? Why is showing null instead of 0? Well, the reason for that is because by default, servlet is not created until it's accessed for the first time. And this could cause problem if one servlet must run before another servlet. Like in our example, if request counter is run before display counter, then everything is fine. But if display counter is run first, the request counter is not run yet, so there's no servlet setting the counter to 0 and store it in application scope. That's why we got null. To handle this type of situations, the solution is to use this load on startup element of the web servlet annotation. So what this one does is it basically tells the application server to start a servlet when the application is deployed, instead of waiting until the servlet is accessed for the first time. Using load on startup is quite simple. We can just specify it as another element for the web servlet annotation, and it takes a value which is the order in which the application server will start the servlets. For example, if you have multiple servlets that needs to be loaded on startup, then one of them can be 1, the other one can be 2, and so on and so forth. And here we'll add this one to request counter. We'll say load on star is 1, and because now we have 2 elements specified for this annotation, the convention is to say URL patterns. But as I said earlier, if we say value, it's also fine. Now, with that, we ensure that this one is always run before display counter. And if I stop the server, and if I try run display counter first, and now it says the counter value is 0 because request counter is already run when the application is deployed. Okay, so this is more or less it for today. Last but not least, some debugging tips. First of all, the most important thing when you run into an error is to read the error messages carefully. Most of the time, the error message is pretty clear about what went wrong. So before you do anything else, make sure you read and understand the error message. Another simple, helpful thing to do is check the source of the generated URL. For example, just by right-clicking on a page and do a view page source. Oftentimes, you run your servlet and you see a blank page, and oftentimes it's not because your code didn't work at all. Maybe because you've generated a wrong HTML tag, so the browser couldn't display it or something like that. And if you do a view source, it's often quite helpful to locate those type of display problems quickly. If you have a very complex page, you can even use some HTML validator or browser plugin to help you to check it. But I don't think we will get to that part because we will use some type of view engine before we create really complex pages. And sometimes the error is logical in the sense that it's not something that's very obvious. You have to really debug your code. And to do that, if you have used Eclipse or any IDE before, you know that you would want to set a breakpoint and then trace the execution of the code and so on. So in Eclipse, it's pretty simple. So just let me stop the server once again, and let's say where do we want to stop? Yeah, let's say I want to create a breakpoint here. So I just double click on this line. You'll see the little dot there. If you double click on it again, it disappears. So double click again, it creates a so-called breakpoint, meaning that once the execution reaches this line, it will stop. So when we run it, instead of run as, we say debug as, and select debug on server. And it will stop at that line and ask us to confirm if we want to switch to the debug perspective. We will say switch, right? And we will be here, and it shows the execution start here. And at this point, we if you look at the right-hand side, we have access to this object's request response counter, and counter we can see that the value is 0, right? And we can also see the request and response object and the servlet object itself. And we can trace the execution line by line. If you look at the menu bar on top here, we can do step over or step into. So that step over will execute one line. Step into will get us into a method call if that line is a method call. Here we can do step over because we don't want to get into the set content method call, set content type method call. We can do step over and so on and so forth. So this way you can walk through your program line by line and see all the values in the method, and it's a great way to debug difficult logical errors. And if you are done, you can click stop, or if you want to continue to the next breakpoint, you can click resume. So I'm going to stop here, and I'm going to switch back to Java EE perspective. So this is it for today. Thank you, and see you in the next video.